Ground fault can occur due to several reasons. Firstly, improper grounding of the underground cable. Secondly, loose connections at the junction box. Thirdly, a defective junction box. Fourthly, a damaged underground cable, and fifthly, a ground loop. Make sure the underground cable is properly grounded at the point of entry into the basement. Check all connections at the junction box and ensure they are tight and secure. A damaged junction box can cause insulation breaches and ground faults. Moisture or mechanical damage can cause the underground cable to become compromised and create a ground fault. A ground loop can occur when multiple grounding paths exist, creating a closed circuit and allowing current to flow through unintended paths. When troubleshooting, inspect the underground cable. Check the cable for any visible damage, such as cuts, punctures, or corrosion. Check the junction box. Open the junction box and inspect all connections. Tighten any loose connections and replace any damaged components. Verify bonding and grounding. Ensure the ground and neutral wires are properly bonded together in the panel box and that the panel box is adequately grounded. Isolate the basement circuit. Temporarily disconnect the underground cable from the basement lighting circuit and check if the 121 volts reading disappears. This will help isolate the issue to the garage or the basement circuit. Check for ground loops. Inspect all grounding paths to ensure they are not creating any closed loops. If possible, remove or isolate any unnecessary grounding paths. If the issue is isolated to the garage, rectify any problems with the underground cable, junction box, or grounding. If the issue is related to the basement circuit, troubleshoot the armored cable and check for damaged insulation or loose connections. Install a ground fault circuit interrupter, or GFCI, in the garage circuit to provide additional protection against ground faults. Seek professional electrical assistance if the problem persists or is beyond your capabilities. The initial voltage spike observed is likely due to capacitive coupling between the hot and neutral wires. This is normal in alternating current circuits and is not necessarily an indication of a ground fault. When dealing with electrical issues, safety is paramount. Always disconnect power before working on any electrical components. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, consult a qualified electrician. Begin by visually inspecting the underground cable for any signs of damage. Look for cuts, abrasions, or exposed conductors. If you find any damage, the cable may need to be replaced. Next, check the junction box where the underground cable connects to the wiring in the garage. Ensure that all connections are tight and secure. Loose connections can cause arcing and create a fire hazard. Use a non-contact voltage tester to verify that the power is off before opening the junction box. Once the junction box is open, carefully inspect the wires for any signs of damage or corrosion. If you find any damaged wires, replace them with new ones of the same gauge and type. Make sure to use the proper connectors and tools to ensure a secure connection. Check the grounding system to ensure that it is properly installed and functioning. The ground wire should be connected to a grounding rod or other approved grounding electrode. The grounding electrode should be buried deep enough to make good contact with the earth. Use a multimeter to measure the resistance between the ground wire and the grounding electrode. The resistance should be as low as possible, ideally less than 25 ohms. If the resistance is too high, the grounding system may not be effective. Check the neutral ground bond at the main service panel. The neutral and ground wires should be bonded together at the first point of disconnect. This bond provides a low impedance path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse. Use a multimeter to verify that the neutral and ground wires are properly bonded together. If you find any problems with the grounding system, consult a qualified electrician for assistance. If you have checked all of the above and the ground fault persists, it may be necessary to use a ground fault locator to pinpoint the source of the problem. A ground fault locator is a specialized tool that sends a signal through the wiring and detects any leakage current to ground. Once the source of the ground fault is located, it can be repaired or replaced. Ground faults can be dangerous, so it is important to take them seriously. If you are not comfortable working with electricity, consult a qualified electrician for assistance. Always disconnect power before working on any electrical components. Use appropriate personal protective equipment such as insulated gloves and safety glasses. By following these tips, you can safely and effectively troubleshoot and repair ground faults in a detached garage. Remember to always prioritize safety and consult a qualified electrician if you have any questions or concerns. In addition to the steps outlined above, it is also important to consider the age and condition of the wiring in the garage. If the wiring is old or damaged, it may be more susceptible to ground faults. In this case, it may be necessary to replace the wiring with new, updated wiring. When replacing wiring, be sure to use the correct gauge and type of wire for the application. Consult the National Electrical Code (NEC) for specific requirements. It is also important to install ground fault circuit interrupters, or GFCIs, in all circuits that serve the garage. GFCIs are designed to detect even small amounts of leakage current to ground and will trip the circuit breaker or fuse if a ground fault is detected. GFCIs can help to prevent electric shock and reduce the risk of fire. When installing GFCIs, be sure to follow the manufacturer's instructions carefully. Test the GFCIs regularly to ensure that they are functioning properly. Another potential cause of ground faults is moisture. Moisture can seep into electrical boxes and wiring, causing corrosion and creating a path for current to leak to ground. To prevent moisture-related ground faults, be sure to seal all electrical boxes and conduit to prevent moisture from entering. Use weatherproof boxes and fittings in areas that are exposed to the elements. Check the garage for any signs of water leaks. Repair any leaks promptly to prevent moisture from damaging the electrical system. Rodents can also cause ground faults by gnawing on electrical wiring. Inspect the wiring for any signs of rodent damage. If you find any damaged wiring, repair it immediately. Seal any holes or openings in the garage to prevent rodents from entering. In some cases, ground faults can be caused by faulty appliances or equipment. If you suspect that an appliance or piece of equipment is causing a ground fault, disconnect it from the power supply and test it with a multimeter. Look for any leakage current to ground. If you find any leakage current, the appliance or equipment should be repaired or replaced. Ground faults can also be caused by improper wiring practices. For example, if the neutral and ground wires are crossed, it can create a ground fault. Be sure to follow the NEC guidelines for wiring practices to prevent ground faults. Always use the correct wiring methods and materials for the application. If you are unsure about any aspect of wiring, consult a qualified electrician. In addition to the above, it is also important to consider the location of the garage. If the garage is located in an area that is prone to lightning strikes, it may be necessary to install a lightning protection system. A lightning protection system can help to protect the electrical system from damage caused by lightning strikes. Consult a qualified electrician for assistance with designing and installing a lightning protection system. Ground faults can be complex and challenging to troubleshoot. If you have exhausted all of the above steps and are still unable to resolve the ground fault, it is best to consult a qualified electrician. An electrician has the knowledge, skills, and tools to diagnose and repair ground faults safely and effectively. Remember, electricity can be dangerous. Always prioritize safety and consult a qualified electrician if you have any questions or concerns. By following these guidelines, you can help to prevent ground faults and ensure the safety of your electrical system. Also, consider the type of underground cable used. If it's an older type without a dedicated grounding conductor, it might be relying on the metallic sheath for grounding, which can corrode over time, leading to poor ground connection. Replacing the cable with a modern one containing a dedicated grounding conductor could resolve the issue. Examine the connection points of the armored cable in the basement. Ensure the connectors are properly tightened and that the armor is making good electrical contact with the metal box it's connected to. Corrosion or loose connections can impede the grounding path. The initial voltage spike you observed could be due to a buildup of static electricity or capacitive coupling, as mentioned earlier. However, it's crucial to rule out any other potential causes. It might be helpful to measure the voltage between different points in the system while various loads are turned on and off to see if any patterns emerge. For example, turn on lights, appliances, or other equipment in the garage and basement to see if the voltage reading changes. Also, try turning off breakers one by one to isolate different circuits and see if the problem disappears. Documenting your findings can help you or an electrician pinpoint the source of the issue. Consider the possibility of a shared neutral. If the garage and basement circuits share a neutral wire, an imbalance in the loads on those circuits could cause voltage to appear on the neutral wire. This is more likely to be a problem if the circuits are heavily loaded or if there are significant differences in the current draw of the devices connected to each circuit. To check for a shared neutral, turn off the breaker for the garage circuit and measure the voltage between the neutral wire in the garage and a known good ground. If you still get a voltage reading, it could indicate a shared neutral. Correcting a shared neutral situation typically involves separating the circuits and running separate neutral wires for each circuit. If you suspect a shared neutral, it's best to consult a qualified electrician. Before doing any electrical work, always ensure that you are following all applicable local and national electrical codes. These codes are designed to ensure the safety of electrical installations and to prevent electrical hazards. Obtain the necessary permits before starting any electrical work. Permits help ensure that the work is inspected and meets code requirements. Keep detailed records of all work performed, including the materials used, the wiring configurations, and any tests that were conducted. These records can be helpful for future troubleshooting or for when you sell the property. Communicate clearly with any electricians or other professionals who are involved in the project. Explain the problem in detail and provide them with any information you have gathered. By working together, you can ensure that the problem is resolved safely and effectively. Regularly inspect your electrical system for any signs of problems, such as flickering lights, trip breakers, or unusual odors. Addressing these problems early can help prevent more serious issues from developing. Consider investing in a surge protector to protect your electronic equipment from damage caused by power surges. Surge protectors can help to prevent damage to computers, televisions, and other sensitive electronic devices. If you have any doubts about your ability to safely perform electrical work, it is always best to consult a qualified electrician. Electricity can be dangerous, and it is important to take all necessary precautions to prevent accidents. Remember, safety is always the top priority when working with electricity. Take your time, be careful, and follow all safety guidelines. This comprehensive approach should help you to identify and resolve the ground fault issue in your detached garage. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult a qualified electrician for any electrical work.